This is the first part of the narrated lecture, chapter 18, amino acid and protein, and we're introducing biochemistry, so studying molecules and their reaction in living organisms. Well, this is just building up upon all the chapters we've seen so far, and they are very important even in nutrition. And I invite you to just look at the principle of chemistry that we introduced so far. Look at table 18.1 and understand the functional group and their importance in biochemical molecule and the reaction. About 50% of your body dry's weight is a protein. So learning objective, be able to describe the different function of proteins and also give some example. Where does it come from? Word protein from the Greek proteos, meaning primary. It's really something very important, primary importance in all living organisms. I just invite you to read the protein's function overview, and I'm just introducing right away the amino acids. Proteins are polymers of amino acids. So in other words, amino acids are the building block of proteins. Every amino acid has a amine group, so dash NH2, and a carboxyl group, COH. You also have the R group called the side chain that is going to be attached to a central carbon. Then I'm going to invite you to just overview all of the protein that exists in living organisms. They exist from 20 amino acids. I will not ask you to memorize them, but I would like you to know that we use a 3-letter shorthand code for every of those 20 amino acids. Now, their sequence is extremely important, and that's going to be what defines the primary structure of protein, and we're going to understand what it means. Going back to amino acids, well, this is where the chemical nature of the side chain is going to bring the different properties and the different function of proteins. Just for you to know, I don't go into the details, but you should know that nature uses only L amino acid for making proteins, and another definition you should know what is a zwitterion. That's a neutral dipolar ion that has one positive charge and one negative charge, so one positive, one negative charge. We briefly talk about those, but you should know the definition of a zwitterion. So amino acids both have an acidic group, COH, and a basic group, NH2. So they can undergo those intramolecular acid-base reaction, and they, in that case, form a zwitterion. Things you need to know is the way you linked amino acid together. That is called the peptide bond. That's an amine bond between two amino acids. So be able to identify a peptide bond, explain how it's formed. We're going to see this, and also be able to look at the amino side and the acid side. So right here you have example, you have valine, cysteine, and when they are linked together, well, this is going to be again where we have a link called a peptide bond between the nitrogen atom and the two hydrogen atom. That's what you have here on the right side. 3 amino acids that are linked together by peptide bond make a tripeptide. When you have many of them, like a polymer, we call those a polypeptide, and a very large peptide, we call those oligopeptide, have hundreds of amino acids, and we call those proteins. So exact sequence of amino acid in a peptide or protein chain is very important, and any variation of that sequence will make a different molecule. We're going to see how important it is, and this is what we're going to see next, the primary structure of the proteins.